أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم أعوذ بالله بسم الله الرحمن الرحيم. Class 12th physics. Our topic is continuous charge distribution. Continuous charge distribution. A system of closely spaced charge is said to be continuous charge distribution. A system of closely spaced charge. If the charges are distributed closely to each other, then we can see the charges are distributed in continuous charge distribution. There are three types of charge distribution. One is called linear charge distribution. Linear charge distribution. Number second is surface charge distribution. Surface charge distribution. Number third is volume charge distribution. Volume charge distribution. We have to discuss these three one by one. When the charges are distributed continuously, the charge is said to be continuous charge distribution. There are three types: linear charge distribution, surface charge distribution, and volume charge distribution. Let us first take linear charge distribution. What do you mean by linear charge distribution? When the charge is distributed continuously over a straight line or over the circumference of a circle, in this case we use the term linear charge distribution or linear charge density. Linear charge density. If the charge is continuously distributed over a straight line or over a circumference of a circle, then we use what? We use the term linear charge. We are always taking this charge, test charge, as positive charge. When the charge is distributed continuously over a straight line, or over the circumference of a circle, in this case we use the term linear charge density. Linear charge density. What? Linear charge density. Linear charge density is shown by lambda. Linear charge density is shown by lambda. It is defined as a charge per unit length. It is defined as charge per unit length. Charge per unit length. Lambda is equal to charge per unit length. What is? When the charge is distributed continuously over a straight line or over the surface of the circumference of a circle, in this case we use the term linear charge distribution. That means charge is distributed over the line, not over the surface. It is distributed over the line. This is also a circular line. This is a straight line. The charges are distributed either on this line or on this line. Then the charges are said to be linear charge distribution. And the term it is called linear charge density. Linear charge density is shown by the symbol lambda. Then this lambda is equal to charge per unit length. Lambda is equal to charge per unit length, or we can say it is Q bata L. L is the length of the conductor, and what is this Q? Q is the charge. And we can say this is the linear charge density, lambda. The linear, it is unit is charge, it is coulomb, for length it is meter. So we can say coulomb meter inverse is the SI unit of what? Linear charge density. SI unit of linear charge, coulomb meter inverse, or coulomb per meter. It will be sometime asked in the examination. Let us let us show. However, in case of non-uniform distribution of charge. However, in case of non-uniform distribution of charge, if the charge is not distributed uniformly, what would be there? The linear charge. We are taking a conductor, a circular conductor. Why the charge is not distributed? Why there is no linear charge distribution? Let us let us take any charge element. Let us take its length dl, small length. Let us take here a test charge Q naught positive. Q naught. So this charge element dl, this charge element dl, this charge element dl may provide how much charge? dq. Small charge dq. Small charge dq. The charge of this dl, that is dq, and its charge is q naught. It may repel or attract each other. So there may be a interaction force that we can show by dl, force of interaction. And let the distance between them, it is equal to r, position vector. And let us take this our unit vector r cap. Its value is 1. However, in case of non-uniform distribution of charge, we divide this line element into very small elements of length dl. Its whole length is l, and its small lengths are in dl. This dl may provide a charge of dq. The whole may provide q. It may provide how much charge? dq. Okay, then we can say the linear charge distribution, the linear charge density distribution, the linear charge density lambda between this dl and this between the element dq and this q naught, or the element dl and this q naught charge, or we can say between dq and q naught, that would be equal to dq divided by dl. dq divided by charge per unit length, charge per unit length, or we can say lambda dl would be equal to dq. Lambda dl would be equal to dq. Hence, the total charge on it would be, we may integrate it. Lambda dl is equal to integral of dq. That would be q is equal to integral of lambda dl. It is the total charge. Again, we know that the force of interaction, force on the charge q naught due to this charge element dl, force df on this charge q naught due to this charge element dl having a charge dq, charge element dl having a charge dq. The force of interaction on this charge due to this charge dq, which is by this charge element dl, is given by, that is equal to df. We know that df would be equal to it is equal to, we know q naught dq divided by 4 pi epsilon naught this r square into r k. We note what is our dq. df would be equal to q naught. Instead of dq, we write lambda dl into r cap divided by 4 pi epsilon naught r square. Okay. Now our total, what would be our total charge? Then we may integrate this total force between this charge and this, that may be integral of this force, that is equal to integral of q naught lambda dl r cap divided by 4 pi epsilon naught r square. R, that would be integral, and this may be cancelled. We may force, total force, that would be equal to, we may put this q naught 4 pi epsilon naught outside, and in other words, integral of lambda dl divided by r square. What would be the length of this? If it is a circular, then we may use this pi r square. Circular, we may use pi r square. No pi r square. We may use 2 pi r circumference of a circle. If it is a circular length, full circle, then we may use 2 pi r square. What is the length? We may use instead of this L. So we can find the force interaction force between this charge element dq on this discharge q naught. What we have done, if the charges are continuously distributed over a layer or over a surface or over a volume, then we may set in this surface linear charge distribution or surface charge or volume charge distribution. A system of closely spaced charge is said to form a continuous charge distribution. There are linear charge distribution. Let us again say, what do you mean by linear charge distribution? When the charge is distributed continuously over a straight line or over the circumference of a circle. In this case, we use the term linear charge density, or linear charge density is shown by lambda. It is defined as charge per unit. This is linear charge density. It is defined as charge per unit length, or we can say lambda is equal to Q by L. We have found it is unit column meter inverse. Okay. In our next topic, we may take surface charge distribution. Thanks. We have found the force between the charge element dl to the discharge q dq. Also, that was our F. We have found F also.